Today we're going to learn about the two innermost planets, Mercury and Venus. Mercury is the innermost planet to the Sun, and it is very similar to the Earth's moon in several different ways. First of all, it's very, very small. It's the smallest planet, and it also almost has no atmosphere, just like the moon. It has lots of lowlands flooded by ancient lava flows, and the highlands are heavily cratered surfaces, so it ends up looking quite a bit like the moon. Most of the knowledge that we have about Mercury is based on measurements and photographs taken by the Mariner 10 spacecraft back in the 70s. Now we're going to take a look at a quick brain pop on Mercury.
You can't see Mercury at this time of night, Moby. Dear Tim and Moby, what planet is closest to the Sun? Love, Rexy 342. Mercury is the planet closest to the Sun and the smallest planet in our solar system. Actually, since it's so close to the Sun, most people can only see it at dawn, just before the Sun rises, at dusk, just after the Sun sets, or during a solar eclipse. Mercury's being so close to the Sun also means that it switches back and forth between being extremely hot and extremely cold. During the daytime, temperatures on the equator can reach 430 degrees Celsius. That's hot enough to melt lead. And at night, especially inside craters at the poles, temperatures can go down to minus 180 degrees Celsius. It only takes 88 Earth days for Mercury to orbit the Sun. But it rotates really slowly, about once every 59 Earth days, which means that its day is almost as long as its year. A cool thing happens because Mercury rotates so slowly and orbits so fast. Sometimes the Sun moves backwards. Well, Mercury's orbit is really unusual. It moves from being very close to the Sun to being much farther away. By the time Mercury rotates once on its axis, it's already completed 2/3 of its orbit around the Sun. Compare that to Earth. In one day here, we've only completed a small fraction of our orbit. On Earth, the rotation of the planet makes the Sun appear to move across the sky. On Mercury, the Sun's path across the sky is influenced by both the rotation and the revolution. That makes the Sun's path there kind of weird. Oh, Mercury doesn't have any satellites, and it's only a little bigger than Earth's moon. In 1974, Mariner 10 showed that the exterior of Mercury looks a lot like our own moon, actually. It's barren and cratered. The information we got from Mariner 10 was surpassed by the images we received from a craft called MESSENGER, which entered Mercury's orbit in March 2011. It showed that Mercury's surface isn't just pocked with craters, there are smooth volcanic plains as well. Yeah, the inside of Mercury is a little like the Earth's inside. It has an iron core and a rocky mantle and a thin crust. The iron core gives it a magnetic field, but it's only about 1/100th as strong as Earth's. No, that's not Mercury either. Fine, it's Mercury.
Another way that Mercury is like our moon is that it is tidally locked. Now, the moon is tidally locked to the Earth, so we always see the same face of the moon. Mercury is tidally locked to the Sun, and so its rotation's been altered by the Sun's gravity, but it's not completely tidally locked. So it doesn't always have the same face facing the Sun, but it does make it rotate on its axis very, very slowly. So like you just saw in the brain pop, once Mercury has gone 2/3 of the way around the Sun, or most of the way around the Sun, it is only rotated on its axis once. So that causes Mercury to have very, very long days and very, very long nights. So you can imagine that the daylight side of Mercury would be very, very hot because the Sun is going to be exposed to it for so long and it doesn't have much of an atmosphere. And the night side, that is going to be dark for such a long time, for many, many years, is going to be very, very cold. So again, here we see that its revolution, or its orbit around the Sun, takes 88 days. And its rotation, how long it takes to rotate on its axis once, its day, is 59 days. So again, like I said, you have that extreme day-night temperature contrast. So on the night side, it can get all the way down to negative 173 degrees Celsius, and on the daytime side it can get up to 330 degrees Celsius. Here's a picture of the Mariner 10. That is the spacecraft that I mentioned that was the first to visit Mercury and take the most detailed measurements that we had at the time. Here is a picture of Mercury, a close-up, and you can see a really nice crater here. And these little rays leading away from the crater are called ejector rays, because when that meteor asteroid hit, it ejected material. You can see it's pretty far out here, so that was a very large impact. Here's another beautiful picture of Mercury where you can really see many different craters, and you can see why it's compared to the Moon. So the surface of Mercury is also very similar to the Moon. It's heavily battered with lots of craters from the period of early bombardment, and it has several large basins. The largest one that you need to know the name of is called the Caloris Basin. And this was such a large impact that it actually messed up the terrain on the opposite side of Mercury. So here we can see a drawing of where the impact happened for the Caloris Basin. And there was so much seismic energy that traveled through Mercury that on the opposite side we see something that we call jumbled terrain from the impact. Lobate scarps are a unique feature to Mercury. These are these curved cliffs like we see right here, and these were probably formed, scientists think they were formed when Mercury was shrinking as it cooled down. So as it cooled down and shrink, you can kind of imagine like the wrinkled surface of an apple or an orange as it starts to shrink. It gets lots of wrinkles on the surface. So that's what these lobate scarps are that we see covering the surface of Mercury. We don't see large maria, which is a surface you're going to hear about when we study the Moon, which are these large, flat, flooded plains, flooded with lava a long time ago. But we do see some intercrater plains here. And these are marked by much smaller craters, which are smaller than 15 kilometers, which still seems pretty big. And also some secondary impacts, which were after that period of heavy bombardment. And remember that the period of heavy bombardment is the time in the solar system's history, right after the planets were formed, that they were bombarded by lots of meteors and asteroids and lots of leftover stuff from planet formation. And the large planets drew in with their gravity all of those objects, and that happened for the first couple 100 million years of the planet's history. The smooth plains are even younger than intercrater plains, and here we see a nice radar map that shows that possibly below the surface there might be some icy deposits. The interior of Mercury is unique because of its metallic core. Now, the other interior planets also have a metallic core, but if you look at Mercury's, its core is such a larger percentage of it than the Earth's core is. So it takes up a very large portion of Mercury's mass, and so that core is over 60% more dense than the Earth's moon. What's interesting though is that even though it has such a large core, its magnetic field is a very small percentage of the Earth's magnetic field. And that's difficult for scientists to explain because a liquid metallic core should produce a much larger magnetic field. So they think that maybe it's a lot more solid than we think. So maybe it doesn't have a liquid metallic core, but maybe it has a solid core. Here is a little overview of the MESSENGER mission, which is the most current mission to visit Mercury. This was launched in August of 2004, and it got to Mercury by 2008, and it started orbiting Mercury in 2011 and gave us a lot of up-to-date information on Mercury. Here's a picture of the Machak crater, which is 60 miles across. It's this larger one here, and there's some interesting ridges. You see some raised, wrinkled ridges here on the crater floor, and then we also have two smaller craters there. This is the largest crater here, Palagnatus. This is 83 miles across, so very, very large. And then here we see some of those curved cliffs, some of those lobate scarps. And the one in this picture is 125 miles long. This is the North Pole, which is a lot less cratered than the rest of the surface. And there are some color differences we see in this picture here, but this is taken through different wavelengths of light. This is not visible light that we're able to see. We see Mercury is pretty much just a gray planet, just like the Moon. Next, we're going to move on to Venus and talk about the next planet away from the Sun. Venus, also known as Earth's evil twin, is an interesting planet, the second one away from the Sun, and we're going to watch a quick brain pop on it to start.
Shh. Dear Tim and Moby, Can you do a movie on Venus? From BLump27. Sure. Venus is the second planet from the Sun, between Mercury and Earth. Besides the Sun and the Moon, Venus is the brightest object in the sky. It's named after the Roman goddess of beauty and love. With a telescope, you can see that Venus actually has phases like the Moon. It has no moons of its own, by the way. Venus is the sixth largest planet in the solar system, just a little bit smaller than Earth. Yep, Venus is known as Earth's sister planet. Its gravity is about 90% of Earth's, which means you'd weigh 10% less on Venus than you do on Earth. And, like Earth, it has an iron core at its center. But that's really where the similarities end. Unlike Earth, Venus's iron core does not create a magnetic field around the planet. Scientists think this may have something to do with its slow rotation. One day on Venus is equal to 243 Earth days. And Venus probably has no life on it. Well, for one thing, it's incredibly hot, averaging over 400 degrees Celsius. That's hotter than Mercury, even though Venus is farther from the Sun. Scientists think Venus is so hot because carbon dioxide makes up about 96% of its atmosphere. All that carbon dioxide traps heat from the Sun, causing an extreme version of the greenhouse effect. Right, if there ever was any water on Venus, it would have long since boiled away. Of all the planets, Venus is considered probably the least fit for living things. Dense clouds of sulfuric acid kept the surface of Venus hidden until the early 1960s, when spacecraft allowed us to get a closer look. Since then, over 20 different spacecraft have been sent to study the planet. A bunch of them have even landed there. Pretty much the entire surface of Venus has been mapped by low-orbiting satellites. Yeah, it's mainly large plains with a few mountain areas sprinkled in there. No, I'm not saying it's boring. I do not play favorites of the planets. I love them all equally. Oh, okay, I guess I don't like Venus that much.
So you might be wondering why we call Venus Earth's evil twin. Well, Venus is 95% of the Earth's diameter and has a similar density, and it's only 30% closer to the Sun. So in many ways, Earth and Venus are very much alike. However, Venus is a deadly hot world of volcanoes, lava flows, and impact craters at the bottom of a deep ocean of hot gas. So it's actually very, very different from the Earth. There are many spacecraft that have studied Venus. Let me show you just a few of them. Here is a short list of the many, many spacecraft that have visited near Venus and gathered information. One of the missions that we'll take a look at, which is a current mission, is called the Venus Express by the European Space Agency. Most of the missions that we look at as we're looking at our solar system are missions by NASA, but this one is not by NASA. This is by the European Space Agency. So we'll explore this one a little bit more in class. The atmosphere of Venus is one of the things that makes it very unique. It is extremely inhospitable, and that's because 96% of the atmosphere is carbon dioxide, only 3.5% nitrogen, and then the rest is water, hydrochloric acid, and hydrofluoric acid. Venus has an extremely high surface temperature, all the way up to 880 degrees Fahrenheit. Venus also has a very unique rotation. Almost all of the planets rotate counterclockwise like the Earth. However, Venus and Uranus do not. Venus rotates clockwise, and its period is only slightly longer than its orbit. This means that Venus's day is longer than its year. There are a few possible reasons for this. One idea is that there was an off-center collision with a massive protoplanet early in its formation. Another possibility are tidal forces of the Sun on its molten core. Early radar images have revealed lots of things about Venus, mountains, plains, and craters, and we've gotten more details from orbiting and actually landing spacecraft. This is a picture here of the surface of Venus taken by the Venera 13. The colors here look a little bit reddish, but that's because of Venus's clouds. If we take away that effect, actually the surface of Venus would be pretty similar in color to Mercury, very dark gray. This is a radar map of the surface of Venus, and we can see a few different surface features here. We see scattered impact craters, volcanic regions, and smooth lava flows. Here's a close-up map of some other features here. We see smooth lowlands and highland regions here, like Maxwell Montes and Lakshmi Planum. Maxwell Montes is 50% higher than Mount Everest. So the volcanoes on Venus are on a much grander scale than we see here on the Earth. There are about 1,000 impact craters on Venus's surface. This tells us that the surface is not very old, because 1,000 impact craters all over the surface really isn't that many, especially compared to surfaces like Mercury and the Moon. So we know that Venus's surface has been reformed in its recent past. We don't find any water on the surface, and it has a very thick, dense atmosphere. We don't see any erosion on the surface, so we don't have any indication that liquid water was ever present here. The craters appear sharp and fresh. We don't have any surface wind, so we don't see any erosion due to that either. When we look at volcanism on the Earth, we commonly find them around subduction zones, like in the Pacific Northwest, where we have Mount St. Helens. We see one plate subducting under another. But we don't find this kind of volcanism elsewhere in the solar system. Volcanism on Venus are all shield volcanoes, and these are found above hotspots. We do have these on the Earth. We see Hawaii is an example of a shield volcano from a hotspot. So all of the volcanoes on Venus and on Mars, which we'll learn about later, are all shield volcanoes. Here's some examples of some volcanoes on Mars, and you can see that on a much larger scale than what we find on the Earth. There are 2 lava-filled calderas there on the top of this one, and it's over 250 miles across. Here are some other volcanic features that we see. We see some long lava flow channels, the longest one in the solar system. And here we see these circular formations here, which are called coronae. And we also find pancake domes. Lakshmi, Planum, and Maxwell Mountains are probably the most well-known volcanoes on Venus. And here we see these wrinkled mountain formations, and this indicates that there was some compression and wrinkling possibly in Venus's past, but right now there are no current plate tectonics going on the surface. Here are some pancake domes in the alpha. Now we're going to take a look at a video of a quick flyover over the surface of Venus. This video was made using data gathered from Magellan. They used radar data compiled on top of topographic data, so the brown is the radar data, and the color that you're going to see in a minute is some topographic data. And the bright colors are going to show us the rougher areas, and the dark colors are the smoother areas. And this is a flyover of the volcano Iden Mons. So that's it for our video on Mercury and Venus. Thanks for watching.